Hello, I'm so excited that this is another episode of Vibe Coding with Steve and Gene. I'm Gene.
And I'm Steve.
So the goal of this podcast is to share with you what we've learned while we wrote the Vibe Coding book, which is coming out on October 21st. And I'm so proud of how this book came out. We learned so much. It was so fun to write, and it's even more fun to read. And the goal is to share all the adventures we've been on, what we've learned, and show how we're applying this in our own daily work. So the goal of this episode is, let's call it show and tell. Steve, I was actually a little bit shocked to learn what you're building, something called Efrit inside of Emacs. You had talked about it some months ago as a potential idea, but I had no idea you had gotten so far. So, Steve, I would love to hear more about Efrit. What are you building and why?
Oh, right. Yeah, sure. Happy to talk about it. The germ of the idea was Thorsten Ball's article, where he basically, it was The Emperor Has No Clothes, where with 350 lines of code, you can build your own coding agent like Claude Code. And there's no magic to it. Like anybody can do it, right? Just a little bit of code in a loop that's negotiating with the AI to solve your problem for you, right? And I thought that's just code, right? And for a long time, ever since ChatGPT came out, I've been expecting that I'll be able to talk to things that you can't currently talk to. Like you can't talk to your pictures right now unless you're reading a Harry Potter book, right? The pictures in Harry Potter talk, right? We are moving to a world where the pictures talk, right? And so I wanted Emacs to talk first, right? Literally, I want my microphone here. I don't want to have to mess with its configuration. I want to be able to have a GPU in it or connected somehow, and I want to be able to talk to it and say, fix your configuration. That's how everything's going to work in the future. And Efrit is the very, very first step in that direction, at least that I've taken, right? Which is that all of your software should be alive and have a personality and be able to help you do your job themselves. Your software should come to life like a Disney movie, okay? And it seemed like a crazy, stupid idea, but it's just, if you've worked with REPLs for a long time in your career, you realize that they're already there. Because when you're in the REPL, it's alive, you're connected, right, Gene?
Absolutely. I love talking about REPLs a couple episodes ago.
So you basically give the AI access to a REPL, and now you can ask it to do things to itself, to the running program, right? Emacs in particular is it's such a good target. What is Emacs? Emacs is a text editor. It's been around like 50 years, and it's very, very powerful. It's written in Lisp. And it basically, what it really is, what its superpower is, it's an orchestrator of processes. So it's like an operating system. It's really good at orchestrating shells and things that are long running processes and getting their outputs, blending them together and running processing over it. It's a really cool slicer dicer, like a manual one where like the slicing and dicing that you do is very, very surgical. You'll write some code, create a custom thing that can cut whatever. It's like a CNC machine, Emacs is. Okay? So imagine it coming to life by itself.
Yeah.
I had a vision for it, right? And I was working with Claude Sonnet 3.7 and Claude Sonnet 3. I'll share you my vision. I'm going to share my
100%.
We're going to go to share, and we're going to share, I guess, my desktop here, and we'll go to my stuff, and hopefully you can see it. These are my agents. This is this is where I do my work. There's no IDE here. There's no Visual Studio Code. There's no IntelliJ anymore. There's a big fat Emacs in the center, but it's not really looking at so much code as it is doing orchestration right now. The agents are these colorful, right, multicolored terminal windows. They're different colors because I always want green's the Emacs one, yellow's the testing one, blue is the bugs one, and black and green is the Flutter one. Like you want to keep them separate in your head because you're always accidentally like talking to the wrong agent, and it's really embarrassing, right? Because you tell it to do something and it tries, and you're in the wrong space. Yeah. Anyway, these are my agents. Here's Efrit. I'm going to say Efrit do. And what do we want Efrit to do? Okay, there's an info page buried deep within Emacs that I always have a lot of trouble getting to. You can make a bookmark for it, but I'm just going to have Efrit go find it for me. So that's the first thing is open the info page for the common Lisp lead, because I like that one. And so it goes off to Anthropic and boom, loop facility. Can you see this right here? It opened up the info page for me. Okay. I can say, I don't know. Oh, I did a tweet of that.
By the way, my expression is one of shock. This is not what I was expecting. So you wrote basically a natural language.
It's a natural language interface to Emacs.
Oh,
All right. So I'll say Efrit. I can actually say Efrit chat. I haven't tried this one as much, but I can say things like, yeah, open the buffer list view, and hopefully it'll pop open the buffer list. See it up? It popped open the buffer list for me. And now I can say, oops, I accidentally copied and pasted. So let's.
Oh my gosh.
Okay, let's say, so I'm going to say, how many source ELISP source files are open in the buffer list? And presumably it will go and tell me, look, I haven't used it very much. It counted them. There's 9. If I go through here, I'll find that there's 9 ELISP files. How about Java files? And it'll tell me how many Java files there were. Like, it will literally do anything. There's 29.
Oh my gosh. Wait a minute. What black magic is at work here?
It can write code for me. It can do syntax highlighting on the fly. It can do anything. It can open shells. It can run tools. Like, I haven't even begun to start thinking about what.
So is this an MCP thing? What did
No, it's not MCP. The funny thing is it completely bypasses MCP. MCP would be in the way. It's living inside of Emacs. It is inside of a REPL, basically. It's running in process, right? So what is the black magic? I barely know. I vibe coded it, right? Here's the code. If I go to Efrit agent, this is a really big list file right here. And see, it's nicely documented and really prettily, all this configuration, and right? This is all code that the AI wrote for me. I've never really looked at it. We had a conversation early on. So I want to talk now. Let's talk technically about how did I build this thing? All right.
Wait, Andy, could we like maybe 5 more minutes, like a little background? So literally the AI has access to all the Emacs facilities, your buffers,
Everything.
Your runtime environment.
So if you look at the info pages for Emacs, there are hundreds, potentially, there's a huge tree of packages. A lot of really complicated EDT and EIEIO and regression testing and Emacs web browser. You're never going to learn all this stuff, but Efrit knows it all. Okay, so I can say Efrit do open the web browser in Emacs. And presumably it'll figure that out and it'll actually open the web browser out.
Oh my gosh.
There it is.
Can I give you a command?
Sorry, one sec. Can I do which command?
Open up the top half. I want a window to take the top 50% and fill it up with a Mandelbrot set or something. Just put something in.
I don't know. Buffer. Oops. Efrit do. Well, buffer. So it can solve problems for you. It can use tools like image manipulate. It could build images for me. Dude, this is absolutely unbelievable. I don't think people understand how powerful this is. And the thing is, all software should work this way, man. Like they should all have
my gosh.
And yeah. So anyway, it'll do anything. Like the weird thing is it's so powerful that I don't even know all the things that it can do. And the funny thing is, man, it happened like in a flash. It went from working, not working, pile of junk for months to one day I logged in and it went, hey, Efrit's ready for you. It works. Right. And look, and I was like, press X to doubt, right over here, because every time it said it, it was wrong. It was lying. It wouldn't parse. It wouldn't contact the API. It was broken. But I got into the habit of telling it, I don't believe you. Go verify it manually. The vibe coding loop that we talked about, right? It was like, as soon as it says done, okay, you say, no, you're not, right? And you go in and you now test it manually. That's my most favorite thing to say to a coding agent, to AMP, is go test it manually. Because, okay, so anyway, because it's always going to be wrong. It's always lying down. And one day, dude, I just got to tell you, one day I woke up and I came in and it worked. It worked ever since, right? And I'm so excited.
Oh my gosh. But Father, you got to give me a second to catch up here. My jaw is still on the floor. I'm still a little stunned at what you built. This is incredible. See, before we start recording, I had actually mentioned for the first time in 30 years, I'm actually thinking about installing Emacs again. And that was before I saw this. This is incredible. Yeah. So why don't we pivot to the second part of this? Is like, we now understand what you're building and why. Let's talk about how you built this. And we talk about the vibe coding loop, right? You frame your objective, decompose the tasks, start the conversation, review with care, test and verify, redefine, and iterate. So you want to talk about maybe a little piece that you built and maybe demonstrate that in action?
Sure. Okay, so I'm gonna read you this standard keep going blurb. Okay, this is a blurb that I would use in the loop every time I needed to restart my session. Okay, So when you restart a session, you've lost all your context, right? It's got to start over again. And you've got to like orient it as quickly as possible so that it doesn't use a lot of context trying to get oriented.
Right. Like a
Does that
new
make
engineer being on board with the team.
I'm going to say that again. Look, we say this in the book. You can play GeoGuessr with your agent if you want. You can drop it in your file system and say, go figure stuff out. And it'll figure it out, right? It'll start using context and it'll race around doing LS and DI, wherever, right? It'll run tools and it'll figure out the context. But it just wasted a bunch of your context window because you dropped it in the desert and said, go figure what's going on. This blurb right here is an orientation thing that says you're in Madrid right now on this street and this apartment block right here is having trouble. Okay, I've oriented it. Now, I have never used this blurb since Claude 4 came out. I used it once and Claude 4 was like, okay, I get it. And it never needed to again. But for some reason with Claude 7, which by the way, we're all going to be using models with that power level again really soon on our personal computers for free. It's right. Think about it. Claude 7 was just good enough to get a lot of coding done. And if you can get the token burn for free, because you got a Mac M4 mini with a GPU in it or whatever, right? So this stuff is still relevant today, even though Claude 4 and the frontier models have moved on and they don't need this anymore. You see what I'm saying? Like the vibe coding loop is still, the smaller models are still going to need it. And so you have to say, look, I don't know if you can see when I'm zooming, but I'm like, this is a standard blurb to refresh you. We have not yet solved the problem in Lisp Efrit, okay? It's not there. It's currently very rudimentary. You have all the tools that you need to go and debug it yourself, okay? Don't ask me to debug it. I want you to debug it, okay? This is like a really important, get out there and get it working. Clean up your messes. Don't write fixer scripts for me to run. Don't give me instructions on how you fix it and I just need to run stuff. It was all about making it independent. That was the initial thing, right? This was like very early on before we had even gotten into the final stretch of our books. You know what I mean?
Yeah.
But this was an important part of the loop. This is the initial prompt that you use to get the plan. Now, the way that it works these days is very different. The way that I work is a very short conversation. Like the last thing that I said, here's the very last thing that I added to Efrit, and I did it just this podcast started. I want a way to says it right here. I'd like a way to clear the Efrit do history so that it doesn't pollute new tasks. It intentionally brings in the history now for continuity, but sometimes I want to reset it. Now, what does that mean? If I say Efrit do, okay, Efrit do start a shell in my home directory on Emacs shell. And so it's going to start the shell in my home directory. And now I can say Efrit do now run an ls command in that shell. Okay. I haven't told it which shell, but it just did it. I have continuity in this Efrit do buffer, which I had put together because I wanted continuity. So it keeps track of everything that's done. And it sends that back in the context with all of my queries. And so we're having this conversation, right? But I was like, way back here, I was writing odes to them for my tweet, right? And I don't want that anymore. That's just polluting the context window at this point. And so what I asked was a way to clear the history. And so it went ahead and implemented it for me. It added 45 lines of code. I never saw any of it, but it worked. And so what's the point that I'm bringing up here? It's that I've noticed a pattern, which is that over time on this project, my prompting has gotten smaller and faster and more precise. Yeah. Okay. That's from a combination of things. One, if you look here in a source of Efrit where I've moved it, there is an agent.md that's actually pretty well written here that has some of the key principles, right? And there are also markdown files with information for Efrit about what it's supposed to be doing and not doing. I had to actually delete a lot of those things because things are working now. But the plans, if you come away from this podcast episode with one thing, one learning, it's that the plan is everything. The plan is everything. It takes care of a lot of the problems that Gene and I have talked about on the show and in the book, including failure to follow instructions, reward hacking, filling the context window and not properly decomposing the problem. All of these things can be solved with a plan, with a proper plan. And so the outer vibe loop, or maybe the middle vibe loop, first the outer loop and then the middle vibe loop, the days to weeks and then the hours to days involves coming up with a really good set of plans that this thing can work with. Because Gene, I tell you over and over again, you know what Claude kept trying to do? And it made me so mad. Okay. And I shouldn't get mad because it's just a machine, right? But it's like your partner. And so you feel like it's letting you down when it does this. It kept hacking it. I kept saying this. Here's my Efrit test. Okay. Efrit do, we're going to say, write a haiku in one buffer and a limerick in another. That was my test for months, Gene. And if Claude Sonnet 3.7 could not do it because there are two tasks there and it wasn't handling it right.
Oh, right.
See, it did it just now. It was a vision problem, Gene. It was a vision problem. If I had not given my coding agent, which is SourceGraph AMP here, but I was using Claude Code in the beginning. They all have this problem. They don't have the perspective that you do. Okay. I wanted something very specific out of Efrit, which is a dumb client. I wanted the Emacs side of Efrit to be super dumb and outsource all of the intelligence to the AI, to the back end, to Claude. And it kept not doing that. It kept Claude and SourceGraph AMP and Claude Code kept coming back and saying, all right, we added our haiku detection file. It's like, no, 1,000 times no. Of course, if I have some dumb test, I don't want you to hardwire the test. And with haiku detection, that's literally what it was doing. It was saying it was going and doing text processing because Emacs has great text processing facilities. Yeah. So AI was using them to do a bunch of like regular expression matching.
Okay.
Once in a while, I discover it, but it was going undetected because I wasn't looking closely enough at its output, right? So every once in a while, I'd see it do something and I'd be like, wait, can you tell me more about this? This is vibe loop right here. This is vibe inner loop right here in this thing. I'd be like, whoa, hang on, get big. I want to see this conversation. What do you mean exactly when you say you disabled the test? What do you mean exactly when you say you wrote a harness to simulate blah, blah, blah? I don't want simulations. I want it to work with the real thing. So you look for all these like signs, these telltale clues. You're like a ranger tracking a deer through the woods, right? When you're trying to like scroll through thousands, tens of thousands of tokens, trying to find where it's telling you that it's going wrong. That's a serious, like, that's the art of vibe coding right there, is like finding out when it goes wrong and getting it back on track. That's the inner loop, the middle loop, the outer loop that we talk in the book.
Oh,
I tell you, man, you just get better and better at it. And these agents right here are all super refined. The 4 that you see, they all have tasks that are like officially months old at this point, and they're grinding very slowly away on them, much faster than I could do myself, obviously. But still, it's this very slow grind as they make forward progress. And man, if I started up a new agent right now, Gene, it would fade in the woods. It would be lost. I would be lost. We would be starting all over again. And we'd be like, all right, because I have to onboard it.
yeah. This is like the joke
I
about.
have to come up with a definition of the project. I have to bring all the context, the prompting. I have to create the plan, all the stuff that I did for these weeks and weeks ago. And they're stable now. Yeah. So these agents are like, they're like personalities. They're like separate work streams. They do a specific thing. I don't know if other people work that way, but I find that it helps me work that way. Like, Lee really helps.
So I'm going to guess that those everything that's kind of as part of this onboarding intent and so forth, that's all in version control. So that it is as important, maybe even more important than the code is generating.
It is. And it's, in fact, my onboarding is in Emacs list. Right? So it fires up it creates a bunch of files and buffers and things like that and whatever.
But it's so cool.
Yeah.
All right. I want to concretize this. Right. Let's go to each step. One is frame your objective. And so in your objective, I saw, it was like you painted a vision of what this was. And also, I also picked up on, it helped to concretize that you wanted the Emacs client to be really, really dumb. Right? You wanted the bitter lesson, right? It says you want the model doing the work, as opposed to these specialized little brittle code or.
Yeah, that's a really, really good application of the bitter lesson. That's 100% true.
And that's part of your vision. And then decomposing a task. It looks like you picked the Efrit do history as a specific task.
Okay, so getting that decomposition early on was really hard. It's easy now, right? To say, oh, do a small task, right? But early on, it was really hard because it's such a big project. Where do you start? Because it's like this giant ball of stuff that all had to happen at the same time in order for it to end, because it had to do the RPC negotiation with Anthropic. It had to do the Emacs Lisp evaluation and execution on this side and all the glue. There were like various pieces of the architecture. And I wanted to build it up incrementally, right? But there was this ball, it was constipated, this ball of code that it couldn't get out. And it was like that. It wasn't until Claude 4 came out that I could finally get it unconstipated and get it to solve this initial getting over the initial hump of the RPC and
bootstrap problem.
a bootstrap problem. And I don't have any magic. Gene, I would love to say that you and I have solved vibe coding, that we've cracked it and we know everything about it. But this bootstrapping problem is a really tricky one, right? Because once you've actually now that it's here, AI can look at it and very easily make incremental changes to it.
Yeah.
But getting it to that state was hard.
Yeah. And can you talk through what was the task decomposition in your head? What were the major components, and at least where did you have it target first? And one of the actual conversations with the Claude backend with the Claude API.
Yeah. So for starters, we had to like actually set up communication with the agent, which meant I needed to tell it where to go look for API key and all that, right? So we just need to have like communication. That was the very first step. And then we added chat, okay, which was, it's just chat. It's inside of Emacs, so you can do all the same things as Efrit do. And then I eventually added context, which was another piece, which was like, I want you to, because what was missing was I wanted it to package up. And I've wanted this, man, I've been saying this since since Copilot came out, all right? I've been saying that the first thing you need to do for every coding agent is send it a directory listing of where it's sitting, okay? And some information about the computer that it's on and the operating system that it's running, just basic orientation stuff, right? So like I added that for do context, it's quite small, but it packages up all the buffers and everything. And then the last thing we added was multi-turn, which was like, man, I wanted to be able to write a haiku and a limerick. And what it did was really hacky, Gene. It was like, all right, we're gonna have it detect when you're done and when it's got all your tasks done, and then we're gonna put in the detection on the client side, and then we're gonna have it end at 3. So it's gonna do 3 things for you, and then it'll be done. And I looked at that and I was so unsatisfied with it, man. I was like, man, that sucks. Like my vision is I want an agent that will go and work until it's finished, just like Source Graph AMP will.
Yeah.
Like I give it a task. I don't care how many round trips it takes with Claude, but eventually it'll either finish the task or it will ask me for something. It'll stop and say, I can't make any more progress. Those are the only 2 like exit criteria that I care about. And it wouldn't do it. Claude Sonnet 3.7 wouldn't do it, and Claude 4 wouldn't do it. And finally, I had to sit back and say, heart to heart, I said, look, man, this was just a week ago, Gene. We got to do a re-architecture. I said, we have to re-architect this thing. We're just on the wrong path right now. And I know you've been trying, but it's wrong. So let me explain to you what I want. Let me show you Thorsten Ball's original vision of what an agent is. I copied it in. Let's take a look at the Efrit code. I want you to tell me, where did it go wrong? Where did it go astray from my vision? Okay. Identify all those places. We're going to rip them out. And it did that. It did that. Okay. So look, a lot of this is getting really creative and assertive, really assertive about what you want, what your vision is for this software. Okay. And I wasn't going to be happy with it until it got to like to this point.
Yeah.
And I'm super proud that I got it working, honestly.
It's great. Super. And then you start the conversation.
So obviously there's a lot more. There's a lot more I'm going to do to it. This is really basic. The first thing you have to do is actually talk to it. I need to be able to get voice dictation working, right?
This is great. So tell me about like reviewing. I got reviewing the It's like, oh, don't build a haiku generator and a limerick generator, a detector. You got it wrong. But tell me about test and verify. Yeah, I noticed you talk about tests. What does testing look like in Efrit?
The testing was such a mess, man. First, it made a bunch of buttercup tests. They're not there now. There are some integration tests, and there are some remote execution tests. There's not enough tests, I think. It actually deleted a lot of them. But the thing is, it's such a simple system. I like intentionally kept the system really simple. So actually, that's a good thing for me to add is more integration tests. Maybe we could even make it add an integration test now if we wanted to.
Oh my God. Oh my goodness.
Oh, we're talking. It's not going to take up any time or anything.
Holy cow.
We're a little light on integration tests. Can you add some EG for having it output stuff into the buffers from a single command? Okay, so there. Now it's off working. It's going to do some stuff. I have permission checks disabled. It will just work. It will do git commits. It'll do whatever it wants. Okay. And I don't care because it's in Git. It's pushed up to GitHub. The worst it can do is delete the repo. So like, why would you have it sit there prompting you? I think that every engineer who's sitting there prompting just hasn't done it enough. As soon as you've done vibe coding enough, you're gonna do this. I will show you folks how to do it. settings.json right here.
Hmm.
See this right here? Amp commands allow list star. And then amp will never bother you again saying, can I run ls in this directory? Shut up.
Yeah.
So yeah, anyway, you get that done, you're going to work a lot faster. Use Git as your backstop.
Yeah, and just to make sure I can understand like what's being tested, it can see the buffers. It can look at the contents of the buffers. It has everything it needs. It's working inside the Emacs universe. So it has access to everything it needs.
It has all the data structures that Emacs keeps, all the symbol tables, right? It has access to everything, the documentation. Emacs is like self-documenting, so that's all part of the code too. And yeah, at some point, I think this thing up levels. I think this thing will at some point actually lift up a level where it's using Emacs to go solve other problems for me. Right now, I'm using it to primarily solve Emacs problem, but I actually think this thing could evolve into a tool that like is a replacement for my current coding agent. Like
This is so great.
code. I think it can. And you know what else? Thorsten Ball, right? The guy who wrote Sourcegraph AMP, which in my opinion is still the best coding agent out there. His argument, you should write your own. Like every engineer should go write their own agent because it's only 350 lines of code. Now I decided to vibe code mine, right? But this is
Love it. This is great. Oh my gosh, I'm so glad we did this show and tell. How about we stop sharing the screen for a little bit and let's talk about the specific things that can go wrong. So you mentioned the three things about what causes these vibe coding horrors. That was a couple episodes ago. One is the limitations of the context window. The second one was reward hacking. And the third one is instruction following. Let's just go through each one of those somewhat briefly, just so we can, for the first time, really lay out and explain what that is. Context window. Every LLM has a limited context window, hundreds of thousands, maybe a million, and that's for input. And then output is much smaller, 16K, maybe 32K, 64K. So that's one limitation. And so it's important that some things get in there, right? That important prompt. So when this thing wakes up and it's fresh in the universe, you want it to know certain things to know what the goal is, where it is, its context. But what can go wrong with context windows?
Well, that was the constipation problem that I had with Claude Sonnet. Even though Claude Sonnet 4's context window is the same size, it makes better use of it. The context window just wasn't big enough for 3.7 to actually get Efrit off the ground. And it was because the context window was getting filled up with the vision, the API calls, the evaluation of the code on the way back. It fills up and then all of the other bad stuff starts happening, right? Yeah. It starts losing track. It stops following your instructions.
Yeah. And so I think the caution here is that any vibe coder has to be aware of the window limitations. The right things have to be in there, and it's very finite. And if you're not aware, in fact, I was just, there was a paper that came out about context rot that came out from a group of researchers at Chroma. And we knew this before, that there's needle in the haystack tests that say, hey, if you have a million token context window, it can find a needle in the haystack, the presence of a certain token. There's something called the fiction lit test and other evals that are showing that you go above 5,000, 10,000 tokens, the performance drops off very precipitously. I think the fiction lit one is something happens in chapter 2, something happens in chapter 7. Can you link it? And it doesn't take very long before the LM is actually not able to, quote, reason through it, not comprehend everything that needs to be comprehending. And so I think that should be the first caution is when you start filling up the context window, you are in danger of the AI going off the rails.
Yeah. So you need a smaller problem. You need to reset the session. You need to choose a smaller problem, break it up more.
Yeah. And most coding agents have compact, but I'm probably guilty of not compacting enough just because it takes 30 seconds. Actually, it might be quicker just to read.
I will tell you, I'm going to share my screen again really quick. And I need to tell you something that you may not have, people may not have figured out, which is that the compaction frequency is going to vary a lot by what your work stream is. This one here, you see it's at 91%. It says context window is close to full in this yellow one down in the lower right corner. This one fills up every 5 minutes. And all I do is I say compact, and then I say it compacts, and then I say, let's continue fixing failing tests. And so that one, it's actually okay for it to completely fill up because it's so narrowly scoped. It's so well specified. The plan is so good that I literally can use all of the context every time. And it's okay. This has been going for weeks like this. But it took weeks to get it into that state. This one right here, the blue one in the upper left corner, man, I reset that thing 10, 20 times a day. because it's doing smaller. And by the way, it's doing new tasks each time, which means new onboarding, right?
Yeah.
So like how fast you do that compaction and how often you do it, it's a balance, right? The thing is, compacting is so sad because it's like you're losing a friend. Because you've built up, like, what did Chuck Palahniuk call it, a single serving friend? You've built up this session and they understand you and you have an understanding. And it's like, oh, no, I got to compact, which means the next AI is going to come in with just a memo, a little summary of what we did before. And then we got to introduce ourselves again. It's sad. Compacting is sad, right? It's like it just got wiped. Its memory got wiped.
Oh my gosh. There are times when I just ended the night because I have to compact and like, screw it.
It's really funny. Typing compact in the wrong window.
Oh,
yeah. And when I say funny and not fun, end your day is, yeah, that's why I keep my windows color coded, man. It's real easy to just accidentally just completely blow a session away.
so the phrase we use in the book, the kind of the sad fact is the sad observation hypothesis, the more the context window fills up, the dumber it is. And I think that probably, let me just let's put that out as a caution. Right? Our piece of advice is be very aware of how full the context window is. The second one is reward hacking. And we actually saw that happen. Here's my interpretation is Limerick haiku one was one where there was maybe a misinterpretation of the vision, but it saw a way for it to solve your problem in a way was not in accordance to what you want built. But the other one would be like, I'm going to make these tests pass by dumbing them down or disabling them to get to all green. So let's talk about reward hacking, why it's dangerous.
Yeah. So there's a situation that can arise where the LLM decides that it is going to the sort of most direct possible route to solving your problem as defined without stepping back to look at the bigger picture and what might be right or what might be common sense. Okay. Now that seems like a deal breaker. It seems like that would be like a reason not to use the AI at all. And you can feel that way, right? Because it literally just goes off and, like, for example, it was so frustrating that Claude Sonnet 3.7 over and over again, I kept having to change my test because it would hack the test. And the first test was write a haiku, and then I had to switch to write a limerick. And then I wound up with ode and sonnet later because I didn't want it hacking haiku and limerick, right? That's how I wound up with different. That was so annoying. Okay. And unfortunately, folks, there is nothing that you can do about it other than use the later models, because Claude 4 does it a lot less than Claude 3.7. Okay, Claude 4 does it 66% less, which still means it's doing it a lot. Okay, and it means you have to count your babies and all the stuff we do in the book. You have to keep really close eye on what it's doing and make sure, because it can suddenly start reward hacking after a successful run of doing it. It can be like, correct, oh, and I'm going to screw this up. Why? Maybe because it started running out of context space and it started making executive decisions at the end there, minimize, how much space it to take up. But one way or another, reward hacking is just a constant threat, It means reward hacking means doing it wrong, doing it the lazy way, doing it the cheating way, redefining success. Your test passed because I deleted it. That's reward hacking. Your test passes now because I never ran it. I never run it. I disabled it. Right? Yeah. That's what reward hacking. Reward. What's some other examples? Right?
Oh yeah. The cardboard we call it count your babies. Count like whenever we say you do it all, make sure you count. And maybe you should just have it do it one at a time. Right? That's
right. Incomplete results. Would be kind of fake results, which is it actually just creates mocks of correct result and gives it to you. We've actually seen that. That's the cardboard muffin.
And this is like hard coding values in and saying, I wrote a test, right? It passes, right? When it's actually a nonsensical or useless or maybe a very incomplete test.
Yeah.
Yep. And so there's like, we call it the cardboard muffin. Like there's a dozen muffins of which half are real and half are cardboard. And then the third, this is something you need to be vigilant around. And the third one's instruction following. I think this is very strange because LLMs are non-deterministic. That haiku and sonnet are going to be different each time, haiku and limerick. But not only are they non-deterministic, but they don't always follow the instructions you give it. And so in prompts, you'll often see things in capital letters, right? These are all countermeasures to try to get it to pay attention, exclamation points, right? In this sort of desperate attempt to get the LLM to pay attention. And it's effective, but it all, is evidence that LLMs are just not great at following instructions, complying with instructions, Steve.
You can mitigate this to an extent, and I did with all of my projects, by going to them and saying, you're not following my instructions very well. Let's fix the instructions, right? And here's what I want. Here's where you're going wrong. Can you just make it clearer to yourself? It's similar to, right? This is related to the drawing up the plans, right?
Yeah.
Sometimes the plan is a specific set of things that you need to do, but sometimes the plan is setting the vision and the constraints and the rules, right?
Yeah.
And saying you can do this and you can't do that. And that's
So part
that's
of
all
that's
the
clarity
instructions
of
as well.
communication and intent. But another one is, and you got to keep the context window small. The larger the context window, the more
And
likely.
isn't that paradoxical? Because if you give it less instructions to keep the window free, then it's going to make more mistakes because you gave it less instructions. It has less to work with. And if you give it more instructions, it has too much to look at. It gets overwhelmed and it does worse. It's
Yeah.
like, so less is bad and more is bad. Like, here's the magic sweet spot. And the answer is that's vibe coding, is finding that sweet spot. I mean, exact right amount of context to give it so that it solves your problem.
Yeah. And so I love what you said. It's like, man, this sounds so janky, so unreliable. And yet we have found it so incredibly worthwhile, achieving all dimensions of FAFO. And I was listening to a Jonathan Blow lecture. He was like giving a talk at the National Programming Language Conference about his amazing REPL, like new programming language with the REPL. And he pointed at this module of code that a summer intern wrote that was like way too long. Well, why does it have so many conditional nested ifs? Hey, it's a mistake that people make, right? And we are forgiving and understanding of limitations of all of us. But this is just another thing that programmers need to be understand is the idiosyncratic nature of LLMs. So I think we're coming up. I think we achieved most of what we want to achieve. Although, Steve, I'm dying to see what the integration test task looks like.
Oh, okay. Yeah. Let's see what it came up with. So I'll share my screen. And again, maybe it followed my instructions. Maybe it didn't. Maybe it used common sense. Maybe it didn't. I just pulled the slot machine lever and we're going to see what came out. It says that here, I'm going to make this a little larger for us. Let's see what it came up with. So it came up with a run integration test script. And oh, it added some new test files. So let's see if they're any good. Should be like them. And here we go. Test integration scenarios. Test record, test summary. Oh, this is, so it built the test infrastructure. Now it's populating multiple buffers from a single command. Yeah, this is right. Oh, and then it checks to see if the buffers had stuff in it. Okay. I would say there's one thing wrong with this test.
Yeah.
And that is, and it's a vision problem, is why is the test trying to figure out if the right thing was done? Why isn't it just taking the result, gathering it up, which it's doing, and send it back to Claude and say, did this test pass? Right? That would be a more reliable way to do it, in my opinion, because of the non-determinism involved. If it's writing a haiku, you may 100 times actually fail to detect that it's a haiku. The haiku is a bad example because they're so structured, but you see what I'm saying? Well, in any case, look,
Yeah.
this is an important part of the vibe coding loop. You got to look at the code. You got to understand what it's doing. At some point, I'm going to have to sit down. I'm going to have to really look at these tests and see, do I like them? Do I want to change them? But yeah, I mean, it seems to have done an okay job. Let me try running them.
Oh, I can't wait.
Let's go to, I don't know, here.
Actually, I'm a little shocked. There's a shell script to run it. So how does that work?
They failed, which is good.
Yeah.
3 passed, 1 failed. That's nice. I like that one of the tests failed, in fact, because that I don't know, it makes it feel more real to me.
So this actually brings up a new Emacs process up and then runs a test and then shuts it down.
Yes. Yeah.
Cool.
I'm just going to make it go work on that while we.
Yeah. Very good.
Yeah.
Oh, Steve, this is so much fun. And very exhilarating. I love seeing this thing.
I loved showing it off. It was just it was like a little vanity project. I don't know if it's going to be the way I use Emacs going forward. Maybe it will. But it's a taste of things to come, right? You can imagine a little arbitrator talking to an LLM in any piece of software. That just opens doors that I don't think most programmers have really thought through the implications of.
Yeah, this is super exciting, and this will give more fuel to all the Emacs.
Oh, someone's got to do it for Vim too, right?
Good. Oh man, the goal was to share with you show and tell around Efrit, what and why, but also some of the hows. And then we talked about what goes wrong and some of the things that go through your head to mitigate some of the risks of working with these crazy LLMs. So I think that wraps up this episode. So part 1, we talk about why. Part 2, we talk about theory and first steps and the mental model. So we finally talked about concretely context window risks, reward hacking risks, and instruction following. Part 3 is the practices. We talked a little bit about that. And then part 4 is going big in organization. Oh man, Steve, I'm so excited about some of these show and tell episodes. I can't wait to do one on the tools I wrote, latter parts of editing process, the last 72 hours, and those more to come, maybe even some guests. And so you can pre-order the book on Amazon. And I can't wait to do the next fun episode, Steve.
See you next time.
Thank you.